Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very nice homemade equation with complex numbers. Now I was thinking about how can I come up with an equation that I haven't done before? I know some people are still going to complain. No matter what you do, they're going to complain. Oh, you keep doing the same problems over and over, so on and so forth. I'm hoping that this is a little different than what we've done before. I know we've done something like z plus absolute value, but this time we have the reciprocal. So does that count as a different problem? I hope it does. Anyway, so here's what we have. How do we solve these kinds of problems? If you have z and z bar in an equation, which is the complex conjugate. By the way, if you're new to complex numbers, go ahead and check out my lecture videos. I also have another channel, my first channel, Cyber Math, where I do number theory and algebra videos. You can also go ahead and check it out if you haven't done so already. Now, to be able to solve this problem, we're going to go ahead and first, what was I saying? I was saying that, okay, if you have z and z bar in the same equation, then you may try to, it will be meaningful to make a common denominator, because think about this. If I have something like this, where I have the z bar in the denominator, right? When you make a common denominator, you're going to multiply z by z bar, which actually gives you the absolute value of z squared. So that might be helpful in some cases. I'm not saying all the time, but that's an identity you should be aware of. But in this case, we don't have that, but we could still make a common denominator. Is that going to help? I doubt it, but you can do it if you want. So here's what I'm going to do. I don't think there's two ways to solve this problem, and correct me if I'm wrong. With the z and z bar type of equations, where you don't have absolute value, you can try to conjugate both sides. That'll give you an additional equation sometimes. But with the absolute value, we don't have that luxury. So I'm thinking there's only one way to solve this problem. Correct me if I'm wrong. So let's do this. Let's replace z with x plus yi. No, that's not a good idea, because what's the name of this channel? A plus bi. We usually use x plus yi for locus problems, where we kind of have a set of complex numbers, infinitely many complex numbers that satisfy a certain equation, where we can graph, because all the solutions are going to be on the graph of that curve. Make sense? For example, a circle. If I had something like the absolute value of z equals 2, that would be a circle, right? Can you identify the center and the radius? Hopefully. Anyways, let's go ahead and plug it in. By the way, I haven't solved this problem before, so I'm not even sure how this is going to work, if it's going to work nicely. What's the absolute value of z? If z is a plus bi, absolute value is the distance from 0 by the Pythagorean theorem. Thanks to Pythagoras, we have this. And now we can go ahead and plug it in, and this should give us the result. I have a feeling this is going to work nicely, because I can see now that B is emerging real quick. Okay, cool. Like I said earlier, I haven't solved it before. I wanted this to be the first time experience. Like, is this going to work well? If it doesn't, you'll see my thought process, and maybe I'll make mistakes, and maybe I'll get stuck and say, okay, too bad, I'm embarrassed. I'm not embarrassed, by the way, if I can't solve a problem, because it's okay to make mistakes. Okay, it's okay to get stuck. You probably see this with other YouTubers like Black Pen, Red Pen too. And by the way, on my other channel, I made a video response to Black Pen, Red Pen. Make sure to watch it. It's a quintic. Okay, now, what do? We put the real parts together like this, and then imaginary part separate, real part and imaginary part. And this is going to be negative 3i, by the way. Cool. This is what's really cool about this problem. I just realized, by the way, that the imaginary part is negative 3, and that happens to be b. Beautiful. Otherwise, we would have to deal with a really complex or maybe complicated equation. And some of them are really hard to solve. One time I got stuck, and you've probably seen it. Anyways, it's okay to get stuck again. Don't worry about it. If you are learning math, that's a long journey, and that's what makes it more fun. It's not the destination, but the journey itself. So this is the real part, and that's equal to 21 over 5. But one thing that's good is that I know b is equal to negative 3. Beautiful. Let's go ahead and write this down. The real part gave us something real hard, right? But we know that b is 3. So we could probably do this. Subtract a from both sides. first. And then square both sides. I would probably do that. And then I would be getting something like this. Not very nice, but nice enough. Okay. And then the next thing I should do is probably plug in the b value. B is -3. So why don't we replace b with that? That's going to give me 1 over a squared plus 9. And then on the right-hand side, I have this. Oh, I was expecting to get something nicer. But anyways, we kind of got stuck with a quartic. How nice. So let's see. We cross multiply next. By the way, I'll show you the result from Wolfram alpha at the end. Let's see if you can find the result from Wolfram alpha, okay? I'll try my best. So now, this equation can be factored, squared, that's what I mean. This is 441 over 25 minus 42 over 5a, 2ab, and then plus a squared, and that'll be multiplied by a squared plus 9 equals 1. When you distribute, you're going to get a lot of nice terms. But I think it would make sense to multiply both sides by 25 so we can get rid of the denominators, because that's going to give us 441 minus 42 times 5, because 5 goes into 25 5 times. You can cross cancel, is 210, 210a plus 25a squared. And then I can go ahead and multiply by this, and then I'll get my quartic, right? Let's see. If you multiply these two things, you get 25a to the 4th power. Cool. I'm kind of doing it in reverse direction. If you multiply these two things, you're going to get minus 210a cubed. Let's make sure we distribute the a squared so we don't miss any terms, plus 441a squared. So a squared is done. Now let's go ahead and distribute the 9. 9 times 441, let's see. It's going to be 3,600 plus 360. That's my thought process here, by the way. Plus the 9, that's 9693. 3969. Good. What a nice number. Plus 3969. And then I should distribute the 441a squared. And that should equal 25. Nice. Let's go ahead and simplify this a little bit. Just a tiny bit. 25a to the 4th. I was hoping to get something divisible by 5, but I don't think that's the case. We'll get minus 210a cubed. And then really, did we get the 441a squared twice, or did I make a mistake? Let's see. I probably forgot to multiply. Oh, I think I multiplied this twice. You know what? I'm going to write it differently because this is really unusual, and I'm kind of missing some terms. So let me go ahead and do this. I want to write it as normal, like this, so I can do it in a more normal way, okay? This feels more natural. Okay, now we're going to distribute the a squared, 25a to the 4th, minus 210a cubed plus 441a squared, because I have a feeling I duplicated something. Yes, I think I missed this one. That will be 225a squared minus, oh, we missed that too. That's interesting. 1,890, right? Is that correct? I believe so. A. And then finally, 9 times this one. And that was 3969, I think so, right? Something like this, if I remember correctly. And that's equal to 25. Let's write it here. Okay. Now we can rearrange the terms a tiny bit. Or we can add these two things. Okay. That gives me 666, the lucky number, a squared, right? And then we get minus 1,890a. And if you subtract 25, you're going to get 3,944 equals 0. Beautiful. There must be a common factor, but 25 is only divisible by 5, so that's problematic. But somehow this quartic should be solvable. I don't know how to solve it, or even if I try to solve it, I could solve it, but that will take forever. Let me just show you what the results are. Like I said earlier, I don't even know what the outcome was going to be, but this is what it is. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.